You might be thinking, why am I wearing a hard hat? Well, it's because we're in this really controlled environment, it's -5 degrees, and there's a genuine risk of icicles falling on my head.
Like everything electric, you'll love our fun-packed Everything Electric expos around the world. Next up, we're in London and Harrogate. Remember, energy and transport professionals go for free on the first day.
From insulation to ventilation to sustainable building materials and renewable energy, we know that our homes need to be made much more energy efficient and sustainable. But how do we test any of this stuff, and how do we know it's going to make much of a difference anyway? Which is what brings us here to Energy House Project 2.0, a world-class research institute led by the University of Salford, which is testing these super low carbon technologies in a really controlled environment.
We had heard a lot about Energy House Project 2.0 and were so intrigued to visit. When you step inside the lab, there's an array of new houses, paving stones, heat pumps and EV chargers, making it feel like a new housing development, except it's inside and with a lot more monitoring and sensing equipment. We caught up with Richard to find out what it's all about.
Where we stood here is one of our chambers. So we have 2 identical chambers. What we can do in each one of these chambers is go down to -20 and up to +40, and we can put wind, rain, solar radiation and snow onto the buildings. So all of those factors totally transform how a building would operate in climatic conditions. So really our job is to take a building, so this is one of our newer buildings stood behind us, and put it through its paces, to stress test the building and see how efficient it is, how much it costs to run, and also any problems with the building that need to be fixed before it goes out there to be built in the field.
The conditions in the lab can be precisely controlled, enabling super controlled experiments. But here in the UK, our temperate climate means on average mild summers and cold but rarely severe winters. So why bother testing at such extreme parameters?
So we go to extreme levels of testing here because first of all, we're an international test facility. Our range of climatic conditions allow us to work within about 95% of the globally populated landmass. So anywhere that we're building houses and living in them across the planet, then we can simulate those conditions. But also it means that we can take a building and we can virtually move it into a different climate. But further to that, and I think the more interesting thing is, does a building work now? And does it then work in 2030, 2050 and 2080 in terms of the anticipated levels of climate change?
And that doesn't mean designing homes just to withstand things getting hotter, but more extreme weather in general, such as colder, windier, wetter and more solar radiation. Homes built today will likely still be inhabited in 100 years' time and beyond, so future-proofing is key, both the buildings themselves and the technologies inside them.
This is really important right now. We're just about to go out to consultation. Hopefully the government's going to come out to consultation soon with what's called the Future Home Standard. So in 2025, in the UK, we will totally change the way that we build our buildings, and they'll be what we define as zero carbon ready buildings. So that's a seismic shift from where we currently are in terms of the building regulations. Now what that means in lay people terms is they'll be more airtight. They will be heated using renewable sources, air source heat pumps for instance. They will have more renewables on them, so solar PV, they'll have things like batteries and obviously the EV will sit next to these buildings in a lot of cases. So we're going to totally change the way that we do that. So we're going to change the way that we build our fabric, and we're going to change the number and the complexity of systems that appear in a building as well. So to do that and to get that right, we have to build, let's call them prototype houses, get these things working first with a view to then scaling them out into industry.
We stepped inside one of these prototype homes, which was decked out with all sorts of new technologies designed to make the home more efficient.
Including this, which is called a thermoskirt, in which heat is radiated from the skirting boards. And they also have one called the thermocurve, which does exactly the same thing, but radiating heat from the coving.
Critically, these prototype homes aren't just set designs made to look like real homes, but the one we were in is an actual home from housing developer Barratt's. And the lab is also working with Bellway. Not only does this help to see if these technologies work in real-world conditions, but means anything the lab finds to improve the buildings can be implemented on Bellway and Barratt's planned 30 to 40,000 homes.
Now, you can have all of these weird and wonderful technologies that are super efficient, but if you're not making sure that they come together in this beautifully choreographed and optimized way, you are going to be wasting energy. And that's exactly what this panel, the Smart Home from Loxon, aims to combat. It controls all of the things like, your electricity use, your heating, your lighting, etc., so that you can absolutely optimize your energy use in your home.
As well as working with housing developers and testing new technologies, Energy House Project 2.0 has a number of other hugely important projects.
We've come over to the other lab, which is a comparatively tropical 4.6 degrees C, and they're testing some other really interesting things, including glazing on that porta cabin there, and here a really important project called Mat Zero, which is a solar-powered heated mat. Now, this tent is one that you would typically find in a refugee camp, where families are sometimes staying for years and taking in things like gas stoves in order to provide heat and cooking, which is enormously polluting. So having an electrical solution would be really significant in making their lives that little bit safer in those refugee camps.
And they're also looking at some slightly more experimental things.
This house here is a prototype flat pack modular building from Vector Homes, and it's built using really advanced materials and really lightweight steel, and we should definitely do an episode on that in the future. The other thing that's really cool here is that we're seeing loads of different innovations in insulation. Now, insulation we know is critically important, not just for thermal comfort in the winter to keep your home warm, but also prevent it from getting too hot in the summer months and having to waste energy on cooling your house down.
This is all well and good for new homes, but there are approximately 27 million existing homes in the UK, of which just 4.1% have solar panels and just 1% have a heat pump. In fact, UK homes are considered some of the least efficient in Europe. So is any of this actually helpful for retrofits and upgrades?
Step away from this place for a minute. We have over the road, over the railway tracks over there, we have a test facility called Energy House, which was our first test facility. And that's a Victorian house, 1900s, 1910, let's call it a Coronation Street type of house. Solid brick walls, single glazed windows, something very different than the buildings that we've looked at today. That was our first facility, and it's been with us 12 years. That is where we look at retrofit. And as pleasant and as interesting it is to look at new builds and all the different technology that goes into them, the big housing problem in the UK at the moment is our old housing stock. And to be fair, Energy House 1 is having far more impact over the last 12 months when we've had the energy crisis and everything that's gone alongside that. And we've done several pieces of research there. So we did the ground-in research for the boiler turn-down campaign, which the government put out last heating season. And that's all about turning your boiler down from something like 74. You turn the heating temperature down to around 60 or slightly above. And that's going to save you, between 10, 12% on your heating bills. So we find things over at that facility that's as interesting as we find here, and they are the real problems. The real problem in the UK is fixing our old housing stock, not necessarily just looking at the new housing stock.
Ultimately, that's what this is all about: tackling present challenges, innovating for the future, and striving to make these advancements accessible to everyone. Please support our Stop Burning Stuff Patreon and help us to tackle misinformation about electric vehicles and clean energy.
Here at Energy House 2.0, we've had a glimpse into the future and seen the technologies that we need if we want to reach net zero here in the UK. And we're so excited to feature some of these technologies on the show in future episodes, and let us know which ones you'd like to see in the comments. Please do make sure to like and subscribe, and if you have been, thanks for watching. Saint-Gobain. That didn't really make sense. Lightweight steel, cool, and cold, woo! Which is what brings us to here, the Future Energy House project. That's not what it's called. The Energy House Project 2. 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 Homes and buildings use so much energy, and clearly step one in